Introduction to probability. Number 1, introduction probability. Andito ang sample space, and probability actions, and the last is consequences of action. Here, examples, discrete and continuous. Today, we'll explore the foundations of probability. Well, it starts with the sample space, then the actions that define probability, followed by examples and the meaning behind probabilities. Now, proceed to the number 2, sample space. This is called omega. Set of all possible outcomes must be mutual exclusive. Then collectively exhaustive. The sample space denoted Q contains all outcomes that could possibly happen. Outcomes must not overlap, mutually exclusive, and together cover every possibility, collective exhaustive. Number 3, examples of sample spaces. True rows of a tetrahedral die Y close parenthesis X and Y. The meaning of this is an element of or belongs to. Now, continuous X and Y where 0 greater than X and Y and greater than 1. Sample spaces can be discrete like rolling dice or continuous like selecting a point inside a unit square. Number 4, probability actions. Number 1, if A is any event, then probability that A happens must be 0 or more. Probabilities can be negative. Number 2, P stand probability. This one, omega, and this one, absolute certain P. Number 3, if A intersection B is equal empty set, then probability A union B is equals probability A plus probability B. A intersection B is equals empty set. Means that events A and B are mutually exclusive. They cannot both happen at the same time. Probability A union B is the probability that either A or B or both happen. Since A and B cannot happen together, they are disjoint. The probability of A or B is just the sum of their individual probabilities. There are 3 fundamental actions of probabilities are non-negative. The total probability of all outcomes is 1, and the probability of disjoint events adds up. Number 5, consequences of actions. actions, we can derive useful properties. For instance, the probability of the complement of A is 1 minus the probability of A. Number 6. Examples of probabilities. Probabilities is equals probabilities A is equal area. In a uniform distribution, each outcome is equally likely for discrete cases. Its count base for continuous spaces is based on area. Next, countable additivity. If A1, A2, A3 disjoint, probability union A is equal sigma probability A. This extends the additivity axiom to infinite sequences of disjoint events. This is crucial when dealing with infinite sample spaces. Next, interpretations of probability. Example of mathematical formalism. If A intersection B is equal empty set, then probability A union B is equal probability A plus probability B. That's what we call mathematical formalism. Next, proceed to frequency. Frequency. Relative frequency is equals total number of value. Frequency of a value. Example, if 5 appears 3 times in 20 values, relative frequency is equals 3 and a half 20 is equals 0.50. Probability can represent long-run frequencies, personal beliefs of betting odds. The interpretation depends on the context, scientific, statistical, or philosophical. And the last, role of probability theory. Framework for uncertain events. When flipping a coin, we don't know to the outcome, but we can say probability heads is equal 0.5, probability tails is equal 0.5. This is how the probability creates a framework for handling uncertainty. Inference. Statistical inference uses probability to make conclusion about a population based on a sample. Example, surveying 100 people to infer national opinion. Example of decision, a doctor deciding between treatments. Treatment A, 70% success, mild side effects. Treatment B, 90% success, severe side effects. The doctor uses probability to weigh success versus risk and make a decision. In short, probability helps us make rational decisions when we can't be certain of the outcome. Example of predictions. Weather forecasting. There is a 60% chance of rain tomorrow. Machine learning. Predicting customer behavior or stock prices. Epidemiology. Estimating how a disease might spread. In short, probability provides the tools to make informed data-driven predictions even when outcomes are not guaranteed. Additivity axioms. This is the additivity axioms. If two events cannot happen together, they are disjoint. The probability of either one happening is the sum of their individual probabilities. Next is probability of the empty set. Probability of empty set. Example, the empty set means the outcome impossible, so the probability of something that can never happen is 0. Now, next is probability of a finite set. If we have a set of discrete outcomes and we want the probability of a set of them, we just add the individual probabilities. Now, next is union formula, inclusion to exclusion. Now, when A and B overlap, we're double counting the middle area, so we subtract the intersection to get the correct total probability. And the last is union probability discrete case. In a union uniform sample space, all outcomes are equal likely if there are n outcomes and A has a k of them. The probability is kilometer. For example, with 6 outcomes and 3 favorable ones, probability A is equals 3/6 is equals 0.5.